Tonight, we're stepping into the quiet, invisible world that rules everything, from the drift of the oceans to the dance of the galaxies. Gravity, a force so familiar that we forget it's even there, yet so powerful it can bend space, shape time, and pull entire stars into place. Across 100 surprising facts, gravity will reveal its hidden personality. The gentle side that holds you to your bed, and the wild side that guides worlds through the dark. You see, most people grow up thinking gravity is like an invisible hand pulling everything downward. But the real truth is much more magical. Gravity isn't really a pull at all. It's more like space itself bending around heavy things. Imagine placing a heavy bowling ball on a soft mattress. The mattress dips, and anything you put nearby will roll toward that dip. That's how space works near planets and stars. They don't pull. They just bend the space around them, and everything naturally slides toward the bend. And here's something even more amazing. The more mass something has, meaning the more stuff it contains, the deeper that bend becomes. A tiny rock barely curves space at all. Earth curves it more. The sun curves it so deeply that entire planets move around it, trapped inside that curved path. As you listen, feel free to picture yourself lying on that giant cosmic mattress, feeling the fabric of space gently curving beneath you. And even though gravity feels strong to us here on Earth, it's actually one of the weakest forces in the universe. It reaches everywhere, but faintly. So faintly that if you were floating between galaxies, gravity would still be there, just whispering, not pulling. But gravity has another hidden power, something almost unbelievable. Gravity can slow down time. Yes, time itself ticks more slowly when you're closer to something heavy. Your feet, being closer to Earth's center, experience slightly stronger gravity than your head. And that means your feet age just a tiny bit slower. It's such a small difference you'll never feel it, but it's real, quietly happening every moment of your life. Even now, as you breathe slowly and drift deeper into calm, time is flowing just a little differently at different parts of your body. That's how sensitive the universe is. Gravity also never turns off. There's no switch, no pause. Even when you sleep, Earth's gravity is hugging you gently, holding you close. Even when you're flying in an airplane or drifting in space, gravity is still there, just weaker. And here's a strange thought. You are also pulling on Earth. Because you have mass, space curves around you too. Not enough to move planets, of course, but enough that the effect is real. You and Earth are actually pulling on each other equally. You're just much lighter, so Earth moves less. Gravity varies around Earth too. Mountains bend space a little more. Ocean trenches a little less. That's why sea level isn't perfectly flat. The planet's gravity is uneven, shaped by everything on and inside it. And then there's the moon. Its quiet gravity reaches Earth every single second, lifting the oceans and creating tides that rise and fall like the planet breathing. Those tides help keep our Earth's spin steady, so our climate stays balanced, like someone gently holding the edge of a turning wheel. The sun does the same thing, stretching Earth just a little, shaping our tides and our seasons. Gravity is always tugging from all directions, creating a beautiful three-way dance between Earth, the Moon, and the Sun.
Gravity doesn't work only on planets. It also pulls on stars. In fact, gravity is the reason stars stay together. Without it, their burning gas would explode outward and disappear instantly. Gravity squeezes them inward just enough to keep that balance, like a steady hand holding a wild flame in place. But gravity also reveals things we can't see. For example, when scientists studied how stars move in galaxies, they noticed something strange. They were moving way too fast. The galaxy should have flown apart if only visible matter was pulling things together. So scientists realized something invisible must be there, making more gravity. They called it dark matter, matter we can't see, touch, or detect directly, but we know it's there because of the gravity it creates. Gravity even affects the biggest structures in the universe. Galaxies group together into clusters, and clusters stick together into giant cosmic webs, all held in place by gravity stretching across millions of light years. And perhaps the most incredible part? Everything you see, Earth, the Moon, the Sun, stars, galaxies, all the familiar things in space, make up less than 5% of the universe's total gravity. The rest comes from things we can't see at all. So even though gravity feels gentle, soft, almost unnoticed as you lie here breathing, it is the quiet architect of everything, the shaper of stars, the builder of galaxies, the keeper of time, the force that holds the universe together as you drift deeper into sleep. Gravity isn't just something that affects planets and stars. It actually helped shape everything you're made of. In the early universe, when everything was just tiny bits of gas floating in darkness, gravity slowly pulled that gas together. Little clumps became bigger clumps, and eventually those clumps grew hot enough and dense enough to ignite into the very first stars. Without gravity's patient gathering, the universe would still be nothing but lonely gas drifting forever. No stars, no planets, no Earth, no you. And inside those stars, something even more amazing happened. Nuclear fusion began. Stars started creating new elements. The carbon in your body, the oxygen you breathe, the calcium in your bones, the iron in your blood. All of it was cooked in the hearts of ancient stars held together by gravity. So when people say, "You are made of stardust," it's not poetry, it's physics. Gravity helped build the atoms that became you. But gravity doesn't just give birth to stars, it also shapes time itself. Picture two clocks, one placed high on a mountain, one placed near the ocean. The one closer to Earth's center, the ocean clock, feels slightly stronger gravity and ticks just a little bit slower. It's such a tiny difference you'd never notice it, but it's real and measurable. Gravity literally bends the flow of time, slowing it down the closer you get to something massive. This means time passes differently for everyone, everywhere. Your feet age slower than your head. A person living in a valley ages slower than someone on a mountaintop. Astronauts age faster because gravity is weaker in space. It's a small effect, but it reminds us that the universe is far more flexible, far more mysterious than it seems. Gravity even tells planets and moons how to move. It keeps Earth circling the sun, and the sun circling the center of the Milky Way. But the sun isn't the only thing that pulls on Earth. Every object in space, even you, exerts a gravitational pull on everything else. If you were floating in space near another person, you would slowly drift toward each other, pulled by gravity's gentle touch. You wouldn't feel it. You wouldn't notice it. But given enough time, the universe would bring you together. Gravity also creates something truly strange near massive objects, something called tidal forces. These forces stretch things. Near a planet, they cause ocean tides. But near something extremely massive, like a black hole, the stretching becomes powerful and frightening. If you fell toward a black hole, gravity would pull your feet harder than your head, stretching your body like a long piece of spaghetti. Scientists actually call this process spaghettification. It's funny to say, but not so funny to experience. Gravity even plays a role in helping planets stay warm. As a planet forms, gravity squeezes it so tightly that the compression creates heat deep inside. Earth's core is still hot, partly because gravity kept squeezing it during formation. Gravity also determines the shape of planets. It pulls equally in all directions, so over millions of years, it rounds out everything, smoothing mountains, erasing sharp edges, and shaping worlds into spheres. Even star clusters, groups of stars packed closely together, are held in place by gravity's constant pull. Without it, stars would drift away like fireflies scattered by the wind. And here's something gentle to imagine as you breathe a little slower. Gravity never rushes. It works quietly, patiently, shaping the universe moment by moment, year by year, billion by billion. It is always there, holding everything together, guiding every orbit, catching every falling piece of dust. It is the universe's softest and oldest embrace.
In space, where gravity is extremely weak, astronauts experience something surprising. Their spines stretch. Without gravity pulling downward on their bodies, the spaces between their vertebrae widen slightly, and astronauts become taller, sometimes by 2 inches or more. It's strange and wonderful, but also a reminder of how deeply gravity shapes us, even in ways we don't feel. But microgravity, that gentle near weightlessness, also makes the body weaker. Bones lose strength, muscles shrink. Your heart even has to relearn how to pump blood. That's why astronauts must exercise every single day in space. Gravity isn't just a force, it's a teacher, constantly training every part of our bodies to stay strong on Earth. Yet while human bodies soften without gravity, stars can be shaped into unimaginable power by it. Gravity can make a star collapse with such force that the entire thing shrinks into something smaller than a city, but with more mass than the Sun. This is how a neutron star is born, a tiny, incredibly dense object where gravity squeezes atoms so tightly that protons and electrons merge into neutrons. A spoonful of neutron star material, just 1 teaspoon, weighs about 4 billion tons. That's the weight of a mountain, all crushed into something you could hold in your hand. Gravity can also spin stars and black holes at unbelievable speeds. Some black holes whirl so fast that the edges of their disks reach nearly the speed of light. Imagine a spinning top that rotates so quickly, time itself slows down near it. That's how powerful gravity can become. And almost every galaxy has a massive black hole at its center, shaping how billions of stars move. Its gravity reaches outward like a silent conductor, keeping entire star systems in orbit, not by shouting, not by force, but simply by being massive enough to bend space around it. Gravity can even trap light in special circular paths near black holes. These paths are called photon spheres, places where light gets caught circling around and around, unable to escape, unless disturbed. It's like light is stuck on a cosmic racetrack made of curved space. And here is something even more puzzling. If you were falling into a black hole, anything you dropped before you would appear to freeze in place at the event horizon, the invisible boundary around the hole. From your point of view, things fall normally, but from the outside, it looks as if time stops. The object hangs there forever, slowly fading away. This strange effect is another hint that gravity doesn't just control movement, it controls time itself. Gravity even shows us things we can't see. When massive objects bend light, they distort the images of galaxies far behind them. Sometimes a single galaxy appears as several copies, stretched into arcs or rings. This effect, gravitational lensing, helps scientists find mysteries like dark matter,
because dark matter adds gravity without giving off light. And gravity doesn't just pull, it sometimes fights. While gravity tries to pull everything together, the expansion of the universe pushes everything apart. We can see this tension in the way galaxies move. Gravity slows the expansion near massive areas, but can't stop the universe as a whole from stretching outward. Even the planets around us feel these pushes and pulls. Their orbits, their shapes, their climates, all are shaped by gravity's quiet decisions. In the background of everything you know, in every corner of the universe, gravity is always working, shaping shapes, bending paths, slowing and stretching time, all while remaining completely invisible. It is the most mysterious sculptor in existence.
Take Saturn, for example. That enormous ringed planet looks so solid and powerful from far away. But gravity reveals a secret. Saturn is actually less dense than water. If there were an ocean big enough, a truly gigantic one, Saturn could float in it. It's strange to imagine something so huge drifting like a giant bubble, yet that's exactly what Saturn's gravity tells us. Jupiter, on the other hand, is so massive that its gravity almost let it become a star. It didn't quite gain enough mass to ignite fusion, but it came closer than any planet ever will. Jupiter is like a star that almost happened, a reminder of how gravity decides which objects become worlds and which become suns. Back here on Earth, gravity does something gentle and beautiful. The moon's gravity pulls softly on our oceans, creating the tides. The water rises and falls, almost like the planet is breathing in and out. Those tides help keep Earth stable, preventing wild changes in climate or rotation. Even the sun plays a part. Its gravity stretches Earth slightly, helping shape our tides and contributing to the rhythm of night and day, month after month, year after year. Gravity doesn't only shape planets, it shapes stars too. Some stars live close together, almost like cosmic partners. In these systems, if one star becomes a white dwarf, a very dense, compact star, its gravity can pull matter off the other star. It's almost like one star slowly sipping material from its companion. Over time, this flow of matter can create explosions so bright we see them from across the universe. Gravity is also responsible for something even more dramatic: the creation of black holes. When a massive star runs out of fuel, gravity takes over completely. It collapses the entire star inward, crushing it into a single point. All the star's light, all its material, all its power gets trapped behind an event horizon, a silent doorway where nothing escapes. It's gravity at its most intense and its most mysterious. And yet, gravity can also be incredibly gentle. On Earth, you weigh a little less at the equator than at the poles. Why? Because Earth bulges slightly in the middle due to its rotation. That extra distance from the center means slightly weaker gravity. You won't feel it, but it's there, quietly shaping your weight as you move around the planet. Even gravity is a little less powerful when you fly in an airplane. Just being a few miles above the ground puts you far enough from Earth's center to change your weight. Not much, but enough that physics notices. Even in deep space where you feel weightless, Gravity is still present. Astronauts in orbit aren't escaping gravity, they're falling with Earth, continuously missing the ground. It's like being in an endless, gentle fall that never ends. That's why they float. Gravity also explains the paths of planets, moons, and asteroids. It's predictable, reliable, and beautifully mathematical. Einstein's equations describe it with astonishing accuracy, far more accurately than Newton's older laws. Newton gave us the idea of a force. Einstein showed us a bending universe. Gravity even determines how fast galaxies spin. If we measure their rotation, we see something surprising. They spin too fast to stay together if we only count visible matter. Something invisible must be adding extra gravity, and that something is dark matter, a mysterious substance we can't see but know must exist because gravity tells us so. At the center of everything, planet, star, galaxy, gravity is the storyteller. It decides how big things become, how long they live, how they move, how they die, and even how time flows around them. As our journey continues, gravity gently teaches us more of its surprising secrets, the ones that shape the planets, the stars, and even our own movements. One of the strangest things gravity reveals is how planets can have unexpected strengths. For example, Venus has almost the same gravity as Earth, even though it has no oceans, no life, and a completely different environment. If you stepped on Venus, ignoring the heat and pressure, you'd feel just as heavy as you do here. Gravity doesn't care about landscapes or weather, only mass. But then there's Uranus, a planet much larger than Earth, yet with weaker gravity. Even though it looks huge, it's made of lighter materials, which means space bends around it less. On Uranus, you'd feel a bit lighter, almost like someone quietly lifted some weight off your shoulders. Gravity can be comforting, but it can also be crushing. Jupiter, for example, has gravity so strong that if you ever tried to fall into it, the pressure would squash you long before reaching the center. Its gravity squeezes its atmosphere so tightly that no solid surface can survive. Stars, too, are shaped entirely by gravity. A star stays alive because gravity pulls its hot gas inward while the star's energy pushes outward. The moment gravity wins, the star collapses and its life ends. Sometimes stars gather in huge groups called globular clusters. In these clusters, gravity pulls stars so tightly together that they crowd around each other like glowing beads packed into a tiny cosmic box. It's beautiful, but also incredibly intense. Even here on Earth, you feel gravity's effects in places you wouldn't expect. During a flight, for example, you actually weigh a tiny bit less, not because the plane lifts you away from gravity, but because you're a little farther from the center of the Earth. Just a few miles of distance is enough to change the pull, even if you can't feel it. And if you drift far out into deep space, floating between planets and stars, gravity never completely disappears. There's always some little pull from something, a planet, a star, a galaxy, even tiny bits of dust. You may feel weightless, but the universe never fully lets go. Einstein helped us understand this better than anyone else. His ideas showed that gravity isn't a force, but a bending of space and time. And because of this, his equations predict the movement of planets with incredible accuracy. They explain tiny details like Mercury's odd orbit, something Newton's laws couldn't solve. Gravity even shapes galaxies in ways we still don't fully understand. Galaxies spin faster than they should based on the matter we can see. The only explanation is that something invisible, dark matter, is adding extra gravitational pull. We can't see dark matter, but gravity tells us it must be there, hiding quietly throughout the universe. At the heart of many galaxies sits a gigantic black hole. And at the heart of every black hole lies a place where gravity becomes so powerful that matter collapses into a point so small, so dense that normal physics stops working. We call this point a singularity, a place where everything that falls in is squeezed into almost nothing. It's one of the most mysterious things in the universe, and gravity is the reason it exists. And as you drift deeper into this gentle cosmic story, you begin to realize that gravity isn't just a force that pulls you down. It's a quiet sculptor, a patient shaper, a steady hand that guides every star, every world, every galaxy. Gravity doesn't just bend space, it bends time. The stronger the gravity around you, the slower time flows. Not in a way you can feel, but in a way the universe measures very precisely. Even right now, time is passing a tiny bit slower at your feet than at your head, simply because your feet are closer to Earth's center. This effect becomes even more important when we send satellites into orbit. GPS satellites, the ones that help phones and cars know where they are, run on clocks that tick faster than clocks on Earth. Why? Because they're farther from Earth's gravity, so time flows a little quicker up there. If we didn't correct those clocks every day, GPS would be off by miles. Gravity shapes time, and time shapes the tools we use to navigate our world. As we move farther out into space, we find gravity at work everywhere. It didn't just shape planets, it shaped the universe itself. Right after the Big Bang, gravity grabbed tiny pieces of matter and pulled them into groups. Some groups became stars, others became galaxies, and others became the long web-like patterns stretching across billions of light years, cosmic filaments that connect clusters of galaxies like threads in a giant cosmic spider web. These galaxy clusters, some of the largest structures ever discovered, are held together purely by gravity. Without gravity, they would drift apart into empty darkness. But gravity holds them close, tying together thousands of galaxies, each filled with billions of stars. And as you drift deeper into the story, gravity reveals another one of its strange abilities. It can change the color of light. When light climbs out of a strong gravitational field, it loses a tiny bit of energy. It stretches into longer wavelengths, turning slightly more red. This is called gravitational redshift, a gentle reminder that even light must obey gravity's quiet rules. In stronger gravity, time slows even more.
If you could stand near a neutron star or a black hole, your minutes would pass far slower than someone's minutes far away. You would age slower. The universe would move faster around you. Gravity becomes a kind of time machine, not one you can travel through, but one that changes how time flows for everyone.
Gravity's strength can become truly unbelievable. If you tried to stand on a neutron star, gravity would crush you instantly, flattening you into atoms before your mind even understood what happened. These stars are incredibly dense, all squeezed together by gravity's unstoppable force. Yet here on Earth, gravity feels gentle and familiar. It keeps our atmosphere held close, creating pressure that allows us to breathe. If Earth had weaker gravity, the air would simply drift away into space like smoke rising from a fire. Gravity even shaped the very roundness of our planet. Planets form into spheres because gravity pulls everything equally toward the center, smoothing out any bumps or edges over millions of years. In some places, gravity creates slingshots, powerful boosts that let spacecraft gain speed by swinging around planets. By borrowing some of a planet's momentum, a small spacecraft can fling itself across the solar system without using extra fuel. It's like catching a ride from gravity, letting the universe push you forward. And in galaxies filled with billions of stars, gravity keeps everything moving in perfect balance. It slows stars near the edges from flying away, pulls gas clouds together to form new suns, and helps give shape to spiral arms, those beautiful swirls you see in pictures of galaxies. Gravity even helps decide how dense something can become. If a mountain grows too tall, its own weight, caused by gravity, will crush the bottom, making the mountain collapse into a shorter shape. Gravity decides how high the world can reach, like an architect setting the maximum height of a skyscraper. Gravity also lets spacecraft borrow momentum during cosmic journeys. When a spacecraft swings around a planet, gravity pulls it inward, but the spaceship escapes at just the right angle, stealing a tiny bit of the planet's motion. It slingshots forward with new speed, traveling across the solar system without needing extra fuel. It's almost like catching a ride on gravity's curved path, letting the universe give you a quiet push. Galaxies themselves move because of gravity. Billions of stars swirl in spiral arms, circling their center in elegant loops. The speed of these stars, so fast and so orderly, tells us something mysterious. There must be more gravity than the stars alone can provide. This hidden mass, dark matter, is like the invisible skeleton of the universe, holding galaxies firmly together. When we look at the edges of space, gravity shapes everything we see. It bends the paths of light, slows the march of time, and decides which stars will live long, gentle lives and which will collapse into violent endings. Even black holes, these silent dark giants, are creatures of gravity. Inside them lies a point where matter is crushed into infinity density, a singularity where gravity becomes so strong that the laws we know no longer apply. Around that point, space folds inward. Time slows almost to a stop, and everything that falls in never returns. Gravity controls everything from the orbit of tiny moons to the formation of massive galaxy clusters. It holds comets in long elliptical paths, guides asteroids through silent darkness, and shapes the glowing disks around young stars where planets are born. As we drift deeper through this quiet universe, gravity begins to show us how delicate and connected everything is, from the air around you to the farthest stars in the night sky. You might not feel it, but during a full moon, you actually weigh a tiny bit more. The moon and the sun both pull on Earth, and when their pulls line up, their combined gravity reaches you. It's not enough to notice, you won't suddenly float or sink, but the universe is always tugging gently on you from different directions. And if Earth spun much faster, something even stranger would happen. The spin would push outward at the equator so strongly that gravity there would weaken. Spin fast enough, and eventually, gravity at the equator could become so light that objects might start to lift off the ground. Gravity decides how tightly planets can hold on to us, and also how gently they might let go. When we drift across space, gravity becomes even more dramatic. A supermassive black hole, the kind that lives at the center of galaxies, has gravity so strong that entire solar systems can orbit around it. Imagine billions of stars, each with their own planets, all swirling around a single invisible point. That's the power gravity holds at the heart of a galaxy. And sometimes, black holes have something even stranger. Rings of light, where photons, tiny particles of light, circle around the black hole again and again, stuck in a perfect loop. Light becomes trapped not by walls or mirrors, but by gravity alone. Inside a black hole, gravity is so powerful that space and time bend inward in ways we can barely imagine. The center, the singularity, is a place where everything is crushed into almost nothing, where the normal rules of physics quietly disappear. For a long time, scientists believed this was all impossible to study, but then we learned how to listen to the universe in a new way, through gravitational waves. These waves are the soft shivers of space itself. They pass through Earth, stretching you a tiny amount, too small for you to feel, but just enough for delicate instruments to notice. We first detected these waves when two black holes collided far away. Their gravity rippled outward like a pebble dropped in a cosmic pond, carrying the story of their collision across billions of years. And because of these waves, we now know black holes don't just exist. They merge, they grow, they shape the universe with every collision. Gravitational waves help us understand the universe in a way light alone never could. While we drift further, the universe shares another strange truth. There may be rogue black holes drifting through space, not part of galaxies, not tied to stars, just wandering silently, invisible except for the gravity they create. They drift like shadowy travelers through the night, passing unnoticed unless they bend light from behind them or tug on nearby stars. Even stars themselves sometimes feel gravity's wild power. When one star swings past another at the right angle, gravity can fling it out of a galaxy, sending it speeding away into the emptiness between galaxies. It's called a gravitational slingshot, and stars launched this way can travel millions of years without ever returning. Gravity also behaves strangely when things get extremely dense. Einstein's equations predict that under certain extreme conditions, gravity might even behave like a liquid, flowing or shifting in ways that don't match anything we see here on Earth. And as we look deeper into space, gravity bends light from distant galaxies, magnifying them or stretching them into long arcs. This lensing effect becomes a cosmic map, showing us the shapes of galaxies hidden behind others and revealing how much dark matter surrounds them. Gravity decides the height of mountains, the lifespan of stars, the shape of galaxies, and even the speed at which the universe grows. It is gentle enough to hold your feet to the ground, but powerful enough to shape the fate of everything in existence. And as we come to the end of this quiet journey through gravity, just stay here with me for a moment, letting your breath slow, letting your body feel a little heavier, and allowing the calm to settle around you like a soft blanket. Tonight, we explored how gravity shapes everything, from the tiniest grain of dust to the brightest galaxies spinning in the distance. We learned how gravity holds stars together, creates black holes, bends light, slows time, and gently keeps you right where you are. If you're still awake, still drifting in that peaceful space between thinking and dreaming, I want to gently invite you to stay connected with this little community we've built. It really helps more people find these calming science stories, and it means a lot to me personally. So if you enjoyed this journey, you can softly tap the like button and subscribe for more peaceful bedtime science every night. You can also share this video with someone who needs a little calm in their evening. Those tiny actions help this channel grow more than you can imagine. And if your eyes aren't too heavy yet, I'd love to hear from you in the comments. Tell me where you're listening from, what time it is in your part of the world, and maybe even which fact surprised you the most tonight. I read every message, and it always feels like we're building a small universe of our own, one sleepy story at a time. But if you're already drifting off, if the story has turned into soft shapes and slow thoughts, then don't worry about anything at all. Just let sleep come to you naturally. Let gravity hold you gently, just like it holds planets in orbit and stars in their place. Whenever you need another calm night, another gentle escape into the universe, I'll be right here waiting with a new journey, a new mystery, and a new story meant to carry you softly into sleep. Good night, dreamer. Rest deeply. And thank you for being part of Bedtime Science Talk.